Demo, provisioning an autonomous database in shared deployment. In this demo, we will see how to provision an autonomous database that is in shared deployment mode. Logging into our Oracle Cloud account, in the navigation menu, go to Oracle Database and click on Autonomous Database. On the Autonomous Database page, you see that you have options to create in your compartment an autonomous database in a dedicated infrastructure, requiring you to create other things before you create your database, or just simply create the autonomous database in a shared deployment mode. And that's what we're going to do. We will just click on Autonomous Database in this radio button, and we will create or provision our autonomous database. Here you see the dialog box to create your autonomous database, confirming you're in the correct compartment, providing an informative display name for your autonomous database. I gave an informative name for my display name, and I also gave it a name for my database. So how I identified this autonomous database and the actual name I would associate to the database. Then the type of workload. Do I wish to create a data warehouse, a transaction processing, a JSON database that will store JSON data in my database to allow my developer team to create applications to access the native JSON data, or provision an autonomous database and associate an Application Express workspace for that database? For now, since I desire and I named it in that manner, I'll create a transaction processing database, or an autonomous transaction processing database, in this case ATP. Do I wish for it to be in a shared infrastructure deployment or dedicated? I leave it at the share. Now I just simply need to tell it the version of my database that I desire. I may do a drop down to see what our versions are available to me. I simply define the number of cores, my OCPU, as well as the amount of storage, and that will be in units of terabyte. I'll leave them each at 1. I draw your attention to a feature of the database, and that is autoscaling. So we want to be able to autoscale the amount of CPU that will be more conducive to your workload. And by checking, you're giving Oracle that capability. Now, I do draw your attention to the other autoscaling capability, and that would be for storage. In a similar manner, when your workload mandates it and you're utilizing it in this amount of storage, we want to provide the ability to scale more storage for you when the time needs. And in a similar manner, both is 3 times what is currently active, both for the CPU as well as for the storage. But the difference is the CPU is checked by default to automatically scale for you, whereas the storage is not automatically checked. So if you do desire autoscaling for storage, you need to check it. But for now, I'll leave it unchecked. Next, I need to provide the password in order to access the database. Now, a friendly reminder, for the autonomous database, you're not logging in as user sys, because Oracle is managing it for you. But we do want to have the access to the database in order to monitor what's happening. But in order to do that, you're not logging in as user sys, you're logging in as user admin. So provide a password for user admin. I enter the password, and it's asking me to confirm the password. And now that I've done that, it asks me how the network I will allow to access a network that will be able to access the database. You may have it to be secured, and they're all secured, but from anywhere, or from a secured access, for example, your virtual private network, or specifically a list of IP addresses, or a restricted access using private endpoints. For now, I'll just select secure access from anywhere. Scrolling down, providing it the type of license, either bring my own license or include a new license with this autonomous database that will be provisioned. I may have the option of providing a contact information, such as the email ID of the managing administrator, for example. If you click on Advanced Options, who will manage the encryption key? By default, it would be Oracle. But if you so desire, in order for us to be able to access everything that is secured and encrypted, you will always need a key. So either provided by Oracle or you may provide that key. You can define maintenance, the type of maintenance, and of course tag that will allow you to use keywords to filter and search on this database. And that's all I need. So let's click on Create Autonomous Database. As you can see, it's in the status of provisioning. Let's give it a few moments to complete the provisioning of our autonomous database. Here you see the status of my autonomous database has completed its provisioning. It has a status of available. We will see how we can perform administrative tasks. But for now, let's just view the information about the database. If you look through all the information in this area, it's basically providing the values that I enter into the dialog box, and whatever values I did not, Oracle will handle it for us. If we scroll further down, even with our newly created database, we always have information of how the database is running. So for now, we don't have a lot of data. We just finished provisioning it, but it provides us all the information. And I draw your attention, though we don't have metrics at this moment or backups, we do have keys. And remember, Oracle managed keys. To protect your database, we will always encrypt and need a key for that encryption. I hope this demo helps you know how to easily create, in this case, provision your autonomous database.
In this demo, we are going to see the network access configuration of an autonomous database in shared infrastructure. As we have seen earlier, autonomous database gives you 3 ways to configure the network access. It can be secure access from everywhere, or secure access from allowed IPs and VCNs, or with a private endpoint only. In this reference model, we have the autonomous database in a public subnet, and access to it is controlled using access control list. The clients can be a system in customer data center, or it can be a compute or database system with a public subnet in customer VCN within OCI. We have an internet gateway configured in the customer VCN, and that will enable access to autonomous database in public subnet. So let's begin the demo. I'm in the autonomous database page of my compartment, OU demo 2. We have the autonomous database instance here, and this is having a network access of allow secure access from everywhere. Here, let me change the network access type. So click on more actions and update network access. So right now the network access is secure access from everywhere. Now let's change it to secure access from allowed IPs and VCN only. You can click on this, and then you need to provide the IP notation type. Within this, we have the list. Either you can give a CIDR block, or you can give a VCN, or you can give a VCN OCID. If you give a specific IP address, only that particular IP will be allowed to connect. If you give a CIDR block, then a range of IPs in that CIDR block will be allowed to connect. Otherwise, you can provide the VCN so that all the systems within that VCN will be allowed to connect. Let me choose IP address and give an IP which is in a separate compartment. This is the public IP of one of my database system. If you want to add more IPs, you can click on plus access control rule. And if you want to add the IPs of your own system, you can click on add my IP address, and then click on update. The lifecycle state changes to updating. So this has updated the network access, and as you can see, the state has changed to available. If you scroll down and check on network access, the access type is set to allow secure access from specified IPs and VCNs. Now, since the network access has been set with specific access control list, let me access the autonomous database from another DB system, which has a different IP than what we provided in the access control list. So here I'm in the OU demo compartment, and this is our database. This has a public IP of 150, 136, 174, 38, and it has a public IP which is different than what we provided in the access control list. I've already logged into the terminal of this database. Let's try to access the autonomous database and see. So this is the terminal for this database. Now let me connect to the database using SQL Plus. So this is the ID with admin user, and this is the TNS connection string. Here the connection is held up; it is not proceeding further. So finally, it ended up saying TNS listener rejected the connection based on service ACL filtering. We cancel this. We'll go back and add the public IP of this database system into the access control list of the autonomous database. We can do it from the autonomous database details page, come to network, click on edit in access control list. So this is what IP which was already existing. We can add to the list separated by comma and save the changes. Now let's go back and try to re-establish the connection and see the results. And here it got connected very fast. So we saw here in this demo how to update the network access type for an existing autonomous database to allow secure access from specified IPs and VCNs. Likewise, you can update the network access to private endpoint only. This was a short demo on network access in autonomous database shared infrastructure. Thank you. Welcome everyone. In this lesson, I'll be sharing with you some details about autonomous database provisioning in dedicated infrastructure in OCI public cloud. Before we get into understanding about provisioning, let me highlight some of the key features of autonomous database in dedicated infrastructure. Unlike shared infrastructure, autonomous database in dedicated infrastructure is a private database in the cloud, and it gives you higher control and customization capability. It provides you more governance control, better cost management in its utilization, and meeting the organization compliance requirement without compromising any of the key benefits of autonomous database. You can separate out databases by department and criticality within the organization with a different licensing model. For example, in each of the sales, HR, marketing, finance, there will be multiple test day production environments with different levels of criticality. You can then customize the provisioning with different licensing model within the organization. You can customize the software update schedule and upgrade policies. This is useful when there is a planned production release. Then you can push the software updates to a later date. For upgrade to any available new version, you can first apply in non-production and check for compatibility within your application. For any incompatibility issue, you can plan to apply the necessary fix, verify, and then plan to upgrade to production instance. Depending upon the application SLA, you can decide how you want to configure HA and DR for your specific container databases to meet those SLAs. For example, you can configure autonomous data guard in cross region for extreme availability of your autonomous database and configure transparent application continuity of the dependent application so that the SLA is not breached. You can customize the over provisioning and peak usage policy of your databases. You can allocate fractional CPUs for certain non-critical databases. You can use the resource management plan to allocate resources so that you can control resource throttling by some of the databases that can affect other critical application databases. Define clean role separation. One group of users who control the operation, define policies and resource allocation, and another group of self-service users who would be actually dealing with the autonomous databases. This is just a quick short overview of few capabilities of autonomous database. Let's further understand briefly what lies under the hood in case of autonomous database in dedicated infrastructure. Talking about the architectural components, autonomous database in dedicated infrastructure has five main components. Firstly, Exadata infrastructure or EXA. This is the core physical hardware on which autonomous database is built upon. This comes in various Gen 2 hardware. The latest in the series being X8M2 and X9M2 with quarter, half, and full racks. The Exadata infrastructure provides an elastic configuration wherein you can start with 2 database servers and 3 storage servers, and you can expand by adding more database servers and storage servers in the same rack. Thus, it provides you an efficient and flexible mechanism to meet the future database growth demands. The next layer in the stack is the autonomous Exadata VM cluster, abbreviated as AVM. This lies atop Exadata infrastructure and serves as a link between Exadata infrastructure and autonomous container database. It consists of a symmetrical virtual machine across all compute nodes. This is the layer where you control networking, license, and certificate management of your dedicated deployment. The maintenance schedule of AVM cluster is inherited from the Exadata infrastructure. The next component is the autonomous container database or ACD, which is multi-tenant architecture in Oracle database. And your autonomous database resides in this container database. Within a single AVM, you can create one or more autonomous container databases. Next is the actual autonomous database, where your application data resides and then managed. Your autonomous database can be hosted in a single node of the autonomous Exadata VM cluster, or it can split into multiple nodes depending upon the number of OCPUs you have allocated. So if the number of OCPUs is 16 or less, then OCPUs are reserved in a single node of the AVM. When more than 16 OCPUs, then they are split across multiple nodes. Lastly is the autonomous backup, which is automatically configured by Oracle. The backup of the database happens automatically, but you have the control to decide when the backup should run. There are certain resource limitations that must be understood when creating your deployment. You can have maximum 12 autonomous container database per autonomous Exadata VM cluster. There can be maximum 200 autonomous databases per autonomous container database. If you are configuring the autonomous container database with autonomous data guard, then you can have 25 autonomous database per autonomous container database. This section is very important to understand before you plan for creating your deployment. As we understood earlier, autonomous database dedicated provides clean separation of role. These are fleet administrators and database administrators or developer role. Fleet administrator, they serve the IT role, whereas the database administrator or the developers, these are basically self-service users who have the privilege to provision autonomous database. A developer may also mean a database user who does not have a cloud account but uses the autonomous database for developing applications. Let's quickly take some more details on each of the roles, that is a fleet administrator and database administrator. A fleet administrator user primarily engages with business to understand the database requirement, current and future demands, compliance needs, and accordingly creates an environment as per their manual budget usage plan. They are responsible for implementing governance policies as per the needs of the department within an organization. It can set various controls, which could be operational, SLA, compliance, resource isolation, and even the cost model. They are responsible for creating, monitoring, and managing the Exadata infrastructure, autonomous Exadata VM cluster, and the autonomous container database. They are granted the required IAM privileges for performing the fleet admin role operation. The database administrator role, on the other hand, is responsible for provisioning, monitoring the health, and managing the autonomous database. It requires them to have IAM privileges to use autonomous container database and the networking, and to manage autonomous backups and databases. They'll have the admin user account access when provisioning the autonomous database. This is a graphical representation of the workflow of a dedicated deployment and the respective component that falls under the control of each role. A fleet admin first provisions the Exadata infrastructure, chooses the hardware shape, then he creates an autonomous Exadata VM cluster and then container databases. There could be more than one user with a database administrator role, having the IAM privileges to access any of the container databases and provision autonomous database as per their needs. This is a representation of a simple versus a sophisticated deployment. In a simple deployment, you choose to create a single AVM cluster and a single container database and place all the databases into the same container database. There is just one service level and maintenance update schedule for all the databases. In a sophisticated deployment, there are more than one container databases. One container database to host all the autonomous databases meant for test workloads of multiple teams. They're isolated from production workloads by having separate container database for each application team. For example, the test autonomous container database has multiple test databases, and there are separate container databases for production workload used by web store and manufacturing. You can allow over provisioning in the test container database. Both the production database can have different update and backup schedules. Also, they can have different SLAs, as in here, web store is configured with autonomous data guard to ensure maximum availability. This is just one of example, but you can add many levels of customization that best meets your organization need. To wrap up this lesson, essentially, autonomous database dedicated gives you greater control and customization in the cloud database deployment. In itself, it provides you strong isolation, enterprise-grade performance, and security with complete cloud automation to make your database deployment experience in Oracle Cloud Infrastructure very simple. Hope this was helpful. Thanks for watching. In this demo, we are going to see how to provision autonomous database in dedicated infrastructure in an OCI public cloud. As seen in the lecture, this is the workflow while provisioning an autonomous database in dedicated infrastructure. The first thing you need to provision is Exadata infrastructure in OCI. Once the Exadata infrastructure has been provisioned, you will use it to provision the autonomous Exadata VM clusters. After your autonomous Exadata VM clusters has been provisioned, these are the infrastructure which you will use to provision your autonomous container databases, which follows a multi-tenant architecture. After your autonomous container databases has been provisioned, you can use it to provision one or more autonomous databases on the container database. And as we know, there is a clean separation of roles when you are provisioning your autonomous databases in dedicated infrastructure. There are two groups of roles. One is the fleet administrator user and the other is database administrator user. Before you could begin with provisioning of the autonomous database dedicated infrastructure, there are a few prerequisite steps you must complete in OCI. You have to create two compartments, say fleet compartment and ADB compartment. The fleet compartment is where all your Exadata infrastructure, Exadata VM cluster, and your autonomous container databases will be created. And the ADB compartment is where all your autonomous databases will be provisioned. You have to create two groups of users, fleet administrator and ADB administrators. You can change the name of the groups as per your convenience. And you have to assign the needed IAM privileges to these groups so that users belonging to this group should be able to provision the different resources which are required for provisioning the autonomous database. And then there are two set of users. One is fleet admins who would be belonging to the fleet administrator group, who would be provisioning the Exadata infrastructure, autonomous Exadata VM cluster, and the autonomous container database. And the DB admin users are the ones who will be provisioning your autonomous databases. And you must create a virtual cloud network. The private subnet will be used by the Exadata, and the public one can be used for provisioning your compute and database resources. So let's begin the demo. In this demo environment, to keep things simple, I'll be using admin user who has all the privileges to create the infrastructure components as well as autonomous database. After you log into your OCI console, click on the hamburger menu, Oracle database, and then choose autonomous dedicated. As we know, the first step is to create Exadata infrastructure. Click on Exadata infrastructure, and then click on create Exadata infrastructure. This opens up the window where you need to provide all the details for your Exadata infrastructure. Give it some display name, keep it OUSCD, and for the availability domain, let it be in the default one. Then choose one of the Exadata system model. If you select, you see the list of Exadata system models which are currently available. Choose X8M2. This is a flex model, and initially you can choose 2 database servers and 3 storage servers. And you can provide your maintenance preference. Click on modify maintenance. You can click on select specify a schedule. Choose the month of the year, then week of the month, day of the week. Then give a specific hour of the day when it should run, and what is the advanced notification period what you want to get from Oracle. Click on update schedule. Right now, let's keep it no preference and cancel it. And you can provide the list of email IDs who would be receiving the notification before the maintenance. Click on create Exadata infrastructure. So our infrastructure provisioning has started. Let's come back and check. Our Exadata infrastructure provisioning has completed, and you can see the number of DB servers and storage servers. And right now we don't have any preference for maintenance schedule, so by default it has taken once every quarter. And this is the model of our Exadata systems what we have chosen, and this is the availability domain. Now let's move on to create the autonomous Exadata VM cluster. Click on autonomous database and click on autonomous Exadata VM cluster. Click create autonomous Exadata VM cluster. We are going to do all the provisioning in demo compartment. So let it be selected. Give it a display name. Select the Exadata infrastructure which we just created. Click on this drop down and select OUSCD. For network setting, we'll choose the VCN which is created in this compartment. And for subnet, we'll choose the private subnet. Then choose your appropriate license type. Let me check a license included. And then click on create autonomous Exadata VM cluster. So this has started the process of provisioning the autonomous Exadata VM cluster. Finally, our autonomous Exadata VM cluster provisioning has got completed. And this is the cluster name. You can check the details on this cluster. For example, what is the network? You can check what is the subnet, and then check what is the maintenance schedule. And this is regarding the resource allocations. What is the total number of OCPUs and how many OCPUs are available? And what is the storage which is available? And so this represents the overall capacity of your current cluster. And using this resources, you will be provisioning your container database. This also gives some information about the current capacity which has been used and which is available, so that you can plan for scaling of the resources. As I said earlier, this is on Exadata 8M2 model, which provides a elastic model, so you can increase the number of DB servers and storage servers on the same rack. Now let's scroll down and create the container database, which is our next step. Click on create autonomous container database. It has already selected the compartment where we are going to create the container database. Choose a display name for your container. Say this container we are going to use for development. So you can put it ACD dev. So whenever there is a requirement to provision autonomous database by development team, they can use this specific container. Next is enabling autonomous data guard. If you need to enable the autonomous data guard, you can click here and provide the region where exactly you want to provision the autonomous data guard environment and what would be the peer Exadata infrastructure in that compartment and the autonomous Exadata VM cluster. This information you have to provide. Since this is a development container database, we need not enable autonomous data guard, so I can uncheck it. But while you are provisioning a production container, then you must enable autonomous data guard. Here again, you can set your preference for scheduling. Click on modify maintenance, and you can choose a custom schedule like months of the year, which week of the month, days of the week, and then you can specify at what hour you want to initiate the maintenance activity. Here we don't have any preference, so we'll cancel this. Click on show advanced option, and this is where you can define policies for your backup and encryption. You can change the backup retention policy. It can be 7 days, 15 days, 30 days, or 60 days. Let's keep the default here as 7 days. Click on encryption key. Here you are going to decide whether encryption is going to be managed using Oracle managed keys or customer managed keys. If you want to manage encryption using customer managed keys, then you have to use OCI Vault Service to create a master encryption key, and then you select this option and provide the details about the vault and master encryption key. Let's keep the default selection here, that is encrypt using Oracle managed keys. And that's all the input what you need to provide for creating your autonomous container database. Click on create autonomous container database. So the provisioning operation has started. Let's wait for some time and then check. Our provisioning of the container database has completed. It's ACD dev. You can check some of the details like backup retention policy we set to 7 days. We did not enable autonomous data guard. This is the VM cluster and the infrastructure, and the maintenance we kept it as regular. Under resources, there are total of 100 OCPUs which are available to provision autonomous database in this container database. There's another information which is present here. This is reclaimable OCPUs, which is the total number of OCPUs which are supposed to be available whenever instance is terminated or you are performing a scale down operation. So this will be reclaimed only after you restart your container database. Now you can go ahead and create autonomous databases. You can scroll down and there's an option to create autonomous database from the autonomous container database page itself. Click on create autonomous database. The compartment is already pre-selected. You can choose a display name for that. So we can give appdev and keep same name for the database name. And choose the workload type. We'll choose here transaction processing. And this time it is on dedicated infrastructure, which is selected by default. Then you can choose whether you want to enable autonomous data guard on this particular container database. You have the option to select those container database which has been enabled with autonomous data guard. In this environment, we don't have any container database which is enabled with autonomous data guard. So let's leave it unchecked. And here this is the default container database which is available. And you also get the message this container database does not have autonomous data guard enabled. Then you can configure the number of OCPU count. You can keep it 1, and storage can be a minimum of 32 GB. We don't need to enable OCP auto scaling, so you can uncheck it, and then you provide the admin credentials. So for configure network access, this is slightly different than in a shared infrastructure, and this is by default disabled. If you want to modify the access control, click on modify access control. Click on this checkbox, and then you have to create an access control rule which should contain the list of IPs that will be allowed to access the autonomous database. Click on the access control rule, choose the IP notation type. You have CIDR block or IP address, and then you choose the values for that, and then save it. Right now I don't have access control list, so I can just cancel it, and then click on show advanced option. So here the encryption key is by default chosen as Oracle managed keys because this is what we had selected while provisioning our container database. And then for management, you can change your character set or national character set, and then click on create autonomous database. So our provisioning of autonomous database in this container database has started. We'll wait for a few minutes for this to get completed. Our autonomous database has been provisioned. You can check the lifecycle state which is available. Let's check few details about this autonomous database. It belongs to the container database ACD dev, which we selected. And here you can see the dedicated infrastructure is yes, which means it's a autonomous database in dedicated infrastructure. In the network access, we didn't create any access control list, but if you want, you can click on edit and add those IPs to be allowed to access the autonomous database. There has been no backup, and the encryption is managed using Oracle managed key. And this is the database version, the character sets which we could change while provisioning the autonomous database. And under resource allocation, this is the OCPU count which you choose and the storage size. The autonomous data guard currently it is disabled because our container database was not enabled with autonomous data guard. So this completes the provisioning of our autonomous database in dedicated infrastructure, and this was the last step of the entire workflow which we saw initially. As in this workflow image, we provisioned Exadata infrastructure, we provisioned autonomous Exadata VM cluster, we provisioned autonomous container database, and we provisioned the autonomous database on this container database. This was the complete demo of how you can provision autonomous database in a dedicated infrastructure in OCI public cloud. Hope it will help you in provisioning your autonomous database in dedicated infrastructure within OCI public cloud. Thank you.